we're looking at is the solid rocket boosters. So we've got these two things, which are solid rocket boosters, which is best described as your basic firecracker. You light it, it goes, and you can't stop it. We talked earlier this week about being able to stop and restart engines, which is a much more difficult task. The center engines on the shuttle here that we use to lift could be stopped and restarted to a certain degree, and they gimbal to make sure that you can make fine corrections and movements. But these were solid rocket boosters, and they were made in sections. And they provided the early lifts versus having all of this. In terms of volume, this is much bigger, so it's much more economical. We're back to the age of financing being the concern rather than beating the Soviet Unions. So we were supposed to be better about safety while this was happening. And what you can see here in this picture up here is this is the problem here. There's black smoke. And what this black smoke represents is gases leaking out of one of the seams of the thing. Now, the issue here, which is what I find disturbing, is for the 23 flights prior to the Challenger disaster, that smoke was also there. And a careful review should have shown that there was gases leaking out. And there are reports by some engineers saying this is of concern. And if we now look back at that first picture I pulled up, you can see on the cross section how this gas leaks through the first O-ring right here, and then the second O-ring comes out and it leaks out. Now, in the case of the shuttle, to make a long story a little shorter, is it can fail anywhere in the 360s around it. If it comes out here, you've got a little blowtorch out here. If that's 180 degrees, it's now hitting what is basically your propane tank of an acetylene torch. The flame went out into the major liquid gas of the shuttle, and of course, catastrophic failure occurred. To me, this is very disturbing. Number one, because of the reasons of it was prevalent in the videos, so they should have known. But the thing that really gets me is the rings are made out of rubber, and they knew that the rubber loses its sponginess as it gets colder. So the colder, the less flexible they are, and cold things get smaller, so it's not pressing as tight against its outer surfaces. And they were concerned about the temperature. This was a January or December launch, I don't remember. It was winter. And it was also unusually cold in that day for the launch, but they were under money pressures because NASA's buzzer is so short. And so someone was doing bad science. We'll get into much worse science later in this trip, but this is the chart they used to decide that it was okay to fly. And this represents the failures of the O-rings as a graph against temperature. I'm sorry, I only have Fahrenheit. I hope people can accept that. So 55 degrees is what is that? 15 degrees? 12 degrees? 13 degrees Celsius? And sure, you can see in this chart that sure, they had two O-ring failures down in the 52 degree range, but you're seeing a range between 52 and 75, and there doesn't seem to be any kind of a correlation with temperature on the O-rings, and that's the answer they were looking for, and that's their mistake. They were looking for reasons to fly, and not looking for the truth. Science isn't about getting evidence to support your conclusion. It is about having a conclusion supported by the evidence. It's exactly reversed. We're having a big problem with that right now around the world, but we're trying to stay debatable right now. So can anybody tell me what's missing or wrong about this data that would lead somebody to a wrong conclusion? This one's a little trick question, but I gave you all the clues you need. Can anybody see what's wrong? I'm sorry? the temperature clearly, there's no correlation. I mean, if all those dots were over there, I agree with you that it would. If you remember earlier, I told you there were 23 flights prior to the bad one. That's not apparent from the chart. What's missing in this chart, if there's 23 flights, why do I only show 6 points? What about the other flights? Well, the other flights had 0 failures. This graph is missing the 0. This is only part of the data. Well, wait a minute. Well, what happened during the other 23 flights? Now, all of a sudden, the data is telling a completely different story. All of a sudden, we are looking clearly that there is a large amount of evidence that as the temperature goes up, you are looking at a much higher probability of 0 failures, rather than how many failures did you get with respect to temperature over 0. How many failures? This was ignored. And I find that reprehensible. When you extrapolate that with the actuaries and the mathematicians, this is your probability curve. And look at the temperature on the day of the launch. It was 29 degrees. It was minus 3 degrees Celsius. You were guaranteed practically a probability of an O-ring failure. Multiple O-ring failures on that flight date. And this information was ignored. And that was not good. And it was an economic decision made rather than a safety issue saved. And I find that, well, I use the word reprehensible, but I'm a New Yorker, so we don't mix words. So, and I can't use the real words I want to use because, but boy, would I like to have them in a room. Anyway, I believe what we're looking at to finish out the story, when it actually flew, you can see the torch literally hitting the side of the tank. And you can see it start to ignite and rupture, and we know that famous picture. I don't even bother showing it because, of course, the shuttle mission were then shut down for about 4 years. That's the irony of it. You saved money because you don't want to miss a launch, and then now you have just tripled the entire budget of the entire space program to compensate for that problem. So trying to save this minuscule amount of money by not delaying the launch, you tripled 3 orders of magnitude the cost by not, just delaying the launch. But anyway, the repair on this, of course, is another U-turn into the thing. They added another O-ring, and they had strict temperature and added another gauge to see if there was gas seepage. And probably things they should have looked at because they had all the evidence. But again, famous quote, Monday morning quarterbacking is very easy. You know what you did wrong after you did it wrong. So, and this was the repair that was basically made. And we won't necessarily go into more detail on that, which leads us to the next great American failure,